Determine if the following table of values represents a linear equation or something else. Then graph it, regardless of whether it is linear or not. Now, in order to determine if an equation, or a table of values that corresponds to an equation, is linear or not, we need to look at the rate of change. Take, for instance, this first table. We can see that all of the values of x in this table are increasing by 1. Now let's take a look at the y values. We can see that here the y values decrease by 1. Here they decrease by 3. Here they increase by 1. And here they increase by 3. Here they increase by 5. This means that the rate of change isn't constant, because the amount that the y's change per x is not always the same, which means this will not be a linear equation. And if we graph these points, we'll see that these points do not all lie on a straight line. So, for instance, negative 3, 9 is here. Negative 2, 6 is here. Negative 1, 5, 0, 6, 1, 9, 2, 14 will be off the grid, and we can see that we have this graph that looks something like this. That's clearly not a line. Now let's take a look at number 2. So we can see that once again the x's are increasing by 1. And let's take a look at the y's. So here the y's are increasing by 5, increasing by 5, and in fact all of the y's in this table increase by 5. Which means if we graph the ordered pairs in this table, we should get a linear graph. Let's see if that really is true. Negative 3, negative 4, negative 2, 1. Negative 1, 6, 0, 11, and the rest of our points won't fit on the grid, but we can already see that this indeed is linear. Let's take a look at the last one, number 3. So, again, we see that the x's are all increasing by 1. And if we take a look at the y's, we see that these are increasing by 2, increasing by 2, increasing by 2, increasing by 2, but wait, we can see here now these values are decreasing by 2, which means that this will not be linear. Let's see what the graph looks like. Negative 3, negative 10. Here. Negative 2, negative 8. Negative 1, negative 6. 0, negative 4. 1, negative 2. And you might think that we're going to get a linear graph, but it's here where the rate of change changes that suddenly we don't get a line anymore. 2, negative 4 is here, and 3, negative 6 is here. So actually we get this V-shaped graph, or an upside-down V-shaped graph. So, to summarize, if you're trying to determine if data from a table is linear or not, you need to take a look at the rate of change. You need to figure out how much the y's are changing per x. If the y's do not change by the same amount for each x, then the graph will not be linear. If, however, the y's change by the same amount for each change in x, that means that the graph will be linear.